Hello everyone. In this video, we are going to determine the surface area of a triangular prism. So this is an example of a triangular prism right here. This is called triangular prism because two of its faces is in a triangular shape. So the two of these faces right here, the front and the back, are actually triangular in shape. Now, here's a very important thing that I would want you to remember before we jump into the details of determining the surface area of a triangular prism. We remember that we use the triangular face, this face right here, as the base. Because others are going to think that the base for this prism that we have here is the rectangular shape that's located at the bottom. That doesn't work for triangular prism. It's always the triangular shape that is considered as the base of this prism. So that means we can go ahead and let this triangle stand because this is not on its base, so we can actually make it stand this way. So if I flip it over, so this triangle is gonna look like this, or this prism is gonna look like this. So we have this sides and we have the sides right here. So this prism right here, it's pretty much the same prism, but this time around it's standing on its triangular base. So we remember that we need to make sure that the base for a triangular prism is always the triangle. So this face that we have right here at the bottom, that face right there is our base, and that's the base, that's the triangular base. We can represent this as B triangle. That's the reason why I have placed here B triangle, just to make sure that we don't take other shapes as the base. It's always the triangle for triangular prism. So I label that as the base, triangular base. The height that we're looking for, the height that is part of this formula that we have here is this part right here. So the height of the prism, so that is represented as the H. And then the perimeter, this refers to the perimeter of the triangular base. Again, I put the triangle because this formula only works for triangular prism. So this triangular red part right here is the perimeter. Perimeter means the distance around the distance around this triangle, which is considered the base. So if we count all of, if we add all of the side lengths here, that would represent the perimeter of the triangular base. So surface area of any solid is actually the sum of all the areas of all the shapes that cover the surface of the object. So if we take the, because in here there are there are two triangular faces and there are three rectangular faces that cover this prism. So if we add all of those, the surface area of those 5 shapes, that would be the total surface area for this triangular prism. So we're going to use this formula right here. At this time, we are going to have an example to see how this formula works. And we are asked to show our work in 2 ways. So we are given this triangular prism right here. So this is 13, that's a 5. This 4 right here is the height, and the 12, the 6 here is the length of this side. So what are we gonna do is we are going to unbox this, if you don't mind me saying unboxing this prism, so if that would make sense. So if we are going to unbox this, we're gonna open the flap. It is gonna look like this. So this triangular prism, if we open it, it's gonna look similar to this. So this is the one that is, that's the one that's at the bottom right there. And then this side right here is the flap that covers the this side right here. And I'm gonna draw the other side over here. So it's gonna go here. And then if I open this flap down, so it's gonna go this way. So that's the flap, and then I open the other side as well. So that would be the this other side right here. So if we close this 4 flaps back, it's gonna go back to this. So what are we doing right now is we're determining the surface area. Again, surface area is the sum of all the areas of the faces of this triangular prism. So if we know the areas of each of these faces, then we go ahead and add them all up. That's the total surface area for this triangular prism. So let's go into and let's look at the measurements for this. So this side matches up to this. So this is 6 right here. And then this side matches up to this, because again, this is the flap. So this is 13. So this is 13 centimeters. This is 6 centimeters. And then for this flap, this is the this is the length, the slant height right here. So that's 5. So this side right here is a 5. That's a 5 centimeters. And then this side right here is the same thing. That would be 13 centimeters. And then we go to the other flap. So it's the same thing. That's 5 and 5. So this is 5 centimeters. And then this side, the length of this is similar to that, or is congruent to this part. So this would be 13 centimeters. And then we have here the 6. And then this 4 is the height of this triangle. So this side right here is 4 centimeters. And then it's pretty much the same thing, because these two are congruent. So this side right here is also, this height right here would also be 4 centimeters. Now we're ready to determine the area for each of these face, or each of this figure right here. So we start with the first one. Area is equal to, that's gonna be 13 centimeters times 5 centimeters. That would equal to 62 centimeters squared. So that's a squared. So that's 62 on this flap. Now this other flap is the same. So then we can go ahead and still multiply 5 times 13. That would be, so I'm just going to show the work here. So that would be 13 centimeters times 5 centimeters is equal to 62 centimeters squared. So that is the area for this flap. Now the area for this in the middle, which corresponds to the one that's located at the bottom. So that is the area that we're gonna have here would be 6 centimeters times 13 centimeters. And if you multiplied those two together, that would come out 78 centimeters squared. So that's the area for this shape. Now the area for this triangle. So the area for this triangle would be, that's gonna be 1/2 of, we have the 6 centimeters times the 4 centimeters. So then we go ahead and that 6 times 4 is 24 centimeters squared. Half of it is 12 centimeters squared. So that's the area for this flap. The same thing for this flap as well. So this would be 12 centimeters squared. Now, to find the surface area, we are going to add all of these areas. So surface area would be equal to the sum of all these. So I'm just gonna add all the surface areas here. We start from the left flap. So that would be 62 centimeters squared plus 78 centimeters squared plus 62 centimeters squared. Then we take both the flap, the triangular flap here. So that would be plus, I'm just gonna write it here, there's no space in there. So that's plus 12 centimeters squared plus another 12 right there. So that's 12 centimeters squared. So if we add all of these together, 62, 78, 62, 12, and 12, that would come out 232 centimeters squared. So this is the surface area for this triangular prism. So again, we used the first method, we unboxed it, and we determined the surface area for each of the flaps, and we add all of them, and that is equal to 232 centimeters squared. Now the other method, because it says here we're supposed to show 2 methods for this, so the other method for this is to first let this triangular prism stand. So it's gonna look like this, and then we're gonna label it. So that's gonna be so this is the triangular base right there, and then it's gonna go that way, then it's gonna go this way. And then so we can, I'm just going to use a broken line for that part. So this is the, I actually make it stand this way. So that this side right here is our base. So that's the triangular base, and this is the height. So then from here, we are going to use this formula. So this formula right here shall be used to determine the surface area for this. This, again, this part right here on top is the first method. This one right here that we're showing up here is the second method. So we first find the perimeter. Let's have the measures for this one first. So in this base, the measures for this would be, this side is 6 centimeters. And then this side right here would be 5 centimeters and 5 centimeters. Again, what I did was I let it stand this way. I flip it over, and so the 6 goes to the back, and then the 5 and the 5 would be in the front. So that's how I got these measures here. And then this one right here is 13. Because again, I let it stand this way, so I make it stand that way. So that's 13. And then the 4 here is actually the line that is perpendicular to the 6 here. So this side right here is 4 centimeters. Okay, so let's find the perimeter first. Before we plug in values here, let's find the values first. So we're looking for the perimeter of the triangular base. So this is perimeter of the triangular base. This numbers that we add. Perimeter means around the triangle. So that would be 6 centimeters plus 5 centimeters plus 5 centimeters, and that is perimeter of this is the number that we're gonna put in here, but I'm just showing the work how we got this numbers instead of just putting it in there right away. So this would be 16 centimeters. That's the perimeter. That's the number that we put in here. So we can go ahead and write that is 16 centimeters. Now the height is the height of the prism. So that would be 13 centimeters. I'm going to write 13 centimeters. And then plus 2 times the perimeter, the area of the base. So what is the area of the base? I'm going to show the work for the area of the base here. So that is B triangle, means that's the area of the triangular base. So the shape of the triangle here, if I were to take this triangle off of the prism, the triangle is gonna look like this. So that's a triangular base. Oops, it should not be here. So if I were to take this off, that would be a triangle. So the shape of that, I'll just draw the shape over here. So the triangle of the shape of the base is gonna look like this. So that's the this is 6 centimeters. This is 5 centimeters. This is 5 centimeters. Again, the height there was 4 centimeters. So this is gonna be 4 centimeters. Okay, so to find the area for this triangle, we don't need the 5 and the 5. We only need the 6 and the 4, because these two are perpendicular to each other. So we can go ahead, since this is a triangle, that would be half of, that's 1/2 of the product between 6 and 4. So again, we don't need the 5, so we can erase this so we don't get overwhelmed by these numbers that are surrounding this triangle. So we can take that off of the picture. And so the numbers that we're adding, or the numbers that we're multiplying, would be 6 centimeters times 4 centimeters. Okay, so that would be half of 6 times 4 is 24. Half of it would be 12 centimeters squared. And that's the number that we put in here. That's going to be 12 centimeters squared. So the next thing that we do is to simplify this. So 13 times 16 would be 208 centimeters squared, plus that would be 24 centimeters squared. And so from here, we can go ahead and add them all up together. That should come out 208 plus 24 is 232 centimeters squared is the unit. So both methods that we have here. So again, the first method that we used was we unboxed it, we opened it up, and then get the measures for each of the get the area for each of the flap and add them all up. That's the answer that we got. Now the other method is to use the formula. So it's up to you which method you're comfortable with. So you can pick any of those. But I'm showing you both methods because sometimes we forgot to memorize this in quizzes and tests. And so the go-to method is by unboxing it and finding the area for each of the flap and adding them up together to find the surface area. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!